Hey everyone, moving into Unit 7, Lesson 4, exponential and logarithmic equations. So looking at how to use the properties um, that we've learned so far and various strategies to solve exponential and log equations. So we will be using multiple strategies for this because it really depends on how the problem is set up. And so starting with exponential equations, I don't really like this, but starting with exponential equations and looking at the two different types. So either we can leave them in exponential form and make the bases match and solve that way, which is preferable because it's a little bit less work. Or if we can't make them match, then we can switch to log form and solve that way. So what this would look like is maybe like we did on the lesson 2 assignment, I believe, where if you have like 2 to the x power equals 2 to the 5th, then x would equal 5. A couple more examples. When you don't have these bases the same, your goal would then be to make them the same. So you look at how you can do that and if there's a relationship between the bases that you have. So you can see here we have 5 and we have 125. Well, 5 and 125 are related because 125 can be written as 5 to a power. So looking at that, we have 5 to the 2x minus 9. Well, that 125 can be written as 5 to the 3rd. So now we've got the same bases. So think about, can we rewrite these so that they match? Because they match, our bases will essentially cancel out, and we can just set our exponents equal. So 2x minus 9 is equal to 3. And we just follow our steps of algebra to solve that. So x equals 6. Right? You can always double check by plugging back in. So 5, 2 times 6 is 12 minus 9 is 3, 5 to the 3rd is 125, so that works just fine. Same thing on the next one. We have 16, we have 4. Right, so your goal is to see if you can write those as the same base. Sometimes it may require changing both values. For this case, we don't have to. We can write 16 as 4 to a power. So we have 4 squared. Now, this x is already in the exponent position, so that has to stay there. So that x was already there. I'm going to do it in a different color. So 4 squared to the x. If you have multiple terms, you would want to put this in parentheses, and you have power to power and multiply. And then over here we have 4 to the x plus 1. All right. So we're going to take 2x and set it equal to x plus 1. So x equals 1. Again, you're welcome to plug that in here. 16 to the 1 equals 4 to the 1 plus 1, which is 4 to the 2, which is 16. So x is 1. Now, when we are doing this, we want to make sure that we have whatever is to the exponent isolated first. So real similar to when we did radicals. Whatever has that radical, you need to get by itself. Here, whatever has the exponent, you need to get by itself. All right, so the first thing we're going to do is get rid of this 3. So if I have 3 times 2 to the x minus 2 is equal to 99, I can divide over my 3. And now I have 2 to the x minus 2 is equal to 33. Okay, well, so here we run into a problem because 33 doesn't have any relationship to R2. We can't get them to match at all. And so if we go back here, we are now in our second type of problem. All right, we can't make the bases match. 33 has nothing to do with 2. So we're going to need to switch to log form and solve. Sometimes we use logs to bring exponents out if we have a variable in the exponent. So we're gonna switch this to log form. Okay. So log base 2 of 33 is equal to x minus 2. Okay. So this is going to be calculator work because we want to find an exact value for x. So you're going to do log base 2 of 33 in your calculator so that we can give a solution with for our x value. So it'll be a decimal. I'm going to pull up a calculator. Hang on one second. Okay, so I cheated a little bit and typed that in my calculator. So this is equal to x plus 2, or x minus 2, and we need to isolate the x, so we're going to add 2 over. So x is equal to 7.0444. You do need to go 4 decimal places out. I will be nitpicky on that. When we're working with these types of decimals, we're going to make sure that we go far enough out that if you were to plug that in and check it, you would get the right answer. So this is this x right here. If you plugged that in, you should get 99. Okay, quick reminder, if you don't remember how to convert this, a to the y equals x is the same as log base a of x equals y. So being able to convert back and forth is what's going to enable you to solve this problem. So knowing that the base here is the base of your exponent, which is the base of your log, right? Your exponent here or here is what your log is equal to. Right? And then this number here, which is this number, is what you're taking the log of. So just understanding where all of those components go when you convert. So again, 4 decimal places, that's not negotiable. But just going through that process and understanding when to convert, how to isolate, and that the whole goal is to get x by itself. So you want to solve for the x value. So go ahead and solve this problem on your own. Now that I showed you the first step, I'm going to pause the video and put it up there. Why that keeps going. Okay, so here you go. Notice that I went ahead and divided by 5 here, and then I typed this whole thing in my calculator at once. Just be careful with parentheses and making sure that it's following order of operations. Again, if you have above an 84, you'll just be able to use your log base function and type that in. Otherwise, you'll have to use the change of base formula, which I will go through. We do want to use approximately here, but by isolating the x first before I type it in, it does give me a little bit more of an accurate answer. Up here, I should have used that approximate symbol as well. Okay. And so that's it. Again, you could plug that in and double check yourself, but you should have the same answer. Okay, so here's a new problem. Maybe. I don't know why that did that. All right. Sorry about that. I was trying to figure out why my recorder keeps going away. Okay, so this one is a trinomial, and you'll see like it's to the second power, which means it's squared. So we're going to factor this, but we're going to use what's called U substitution to do so. And this is something you'll use quite a bit in some of your upper level math classes. It's a way to kind of simplify it and see where we're going without all the complicated variables and numbers and all that going on. So we're going to let U equal e to the 2x. I lied. E to the x. And so everywhere we have an e to the x, we're going to plug that in. So e to the 2x minus e to the x minus 6 equals 0. We're going to replace e to the x with a u. So u squared, so that 2 just comes down, minus u minus 6 equals 0. Well, this factors. Whatever multiplies to negative 6 and adds to negative 1 would be u minus 3, u plus 2 equals 0. So we can solve those out. So u equals 3 and u equals negative 2. I don't know why that took me so long, sorry. I was thinking about where to go next. And then we replace back what our u is so that we can finish this problem. So u is e to the x. So over here, e to the x is equal to 3. Well, that doesn't help me because e is an irrational number. So I have to convert it. So log base e, and remember, reminder, log base e is your natural log. And so the natural log of 3 is equal to x. Okay, and you can just type that in your calculator. You should have a natural log button. I'm going to come over here real quick before I switch screens and do that, and do the same thing. E to the x is equal to negative 2. Well, the natural log of negative 2 is equal to x. This is no solution. It's an extraneous solution. Because if you recall, the domain of this function should be from 0 to infinity. We can't have those negative numbers in there when we're dealing with natural logs. So our x values won't be negative. And so this one doesn't work. For this one, you're just going to type that in your calculator. I don't know if my calculator here has an LN button or not. I don't see one. So I'm going to cheat again a little bit and go to my completed notes. And still this answer here. So x equals 1.908, maybe. Nope, didn't get it. X equals 1.0986. Okay. So again, that one crosses out. It's no solution because of the domain, and that would be your answer. Okay, so switching gears here for a minute into logarithmic equations, it's going to be really similar um, as far as kind of your thought processes here, being able to switch to exponential form when you need to. Um, so can you get the log by itself? Can you make it equal just a number so that you can switch to exponential form? Or do you have the same base? So do you have log base 2 of 7 equals log base 2 of x, whereas x would just equal 7? Do you have something like that that you can do? Now there are some of your rules from lesson 3 that you'll come into play here as well, as far as bringing logs together and pulling them apart. Make sure you check all equations in the original equation, and this is because we do get a lot of extraneous solutions with this, so make sure you check for that. You need to make sure the base is positive and that you're taking the log of something that's positive. We won't take logs of negative numbers. That has to do with your domain value. Okay, so solving this and rounding to the nearest thousandth. So this would be like case 1. We have a log that is set equal to a number. So we're actually going to convert this to exponential form. So remember that the natural log is base e. So we have the natural log of 2 plus x is equal to 1. Well, that means that e to the 1 equals 2 plus x. So e minus 2 equals x. And that would be something, again, that you're just going to type into your graphing calculator, scientific calculator, whatever the case may be. Okay, so I typed that in my calculator, and there is your x value. Plugging this in and checking, I went to my thousandths, so I'm just going to take the natural log, and again, typing this in my calculator right now, 2 plus 0.718, and I get 0.99989, so that rounds to 1. And the inaccuracy has to do with the fact that my 0.718 has been rounded. Okay, so I'm going to go ahead and pause the video and have you try this next one because it's the same type. Okay, here's my solution. So this one, when we convert it, because of where the variable is, we got x squared equals 18, so that's just a matter of taking square root of both sides. Please note that usually here we would do plus minus 3. Negative 3 won't work as a base, so we take that answer out, and x is 3. This next one is really a matter of remembering that so long as we have the same base on our logs, they essentially, I hate using the word cancel out, but we can essentially ignore them. If the logs are the same, then that means what we're taking the log of must be the same. So 2x is equal to 24 minus x squared. Well, this x squared right here means that we're now solving a quadratic. So I'm going to work to get this set to 0. So I'm going to actually add x squared and minus 24, subtract 24, so that I have x squared plus 2x minus 24 equals 0. And then factor this down. So x plus 6 and minus 4. So x equals negative 6. X equals 4. Again, noting that this one doesn't work. So this is my answer. Plugging that in to double check. I get log base 3 of 8 equals log base 3 of 24 minus 16, which is 8. So log base 3 of 8, log base 3 of 8, that all checks out. Okay, So know where to start on these problems is going to be the key. Okay. Same thing here. This is a log base 10, if that's not there, of x squared is equal to 2. So it's this whole thing, it's not just the 2. 10 squared is equal to x squared. Well, now my exponent's the same, which means my base must be the same. So x must be 10. I don't know what just happened. Okay. So in lesson 3, you talked about how to expand, how to condense, how to use all of those properties of exponents. And now those are going to come back into play. So you can see this next problem is a little bit different because we have 2 logs, but we don't have the ability just to cancel them out because of this 4 in the middle. Okay, we can't isolate the log and get it set equal to a number because there's 2 of them. But we can get all logs to one side. And start by doing that. So I have log x to the 5th minus 3 log of x is equal to 4. Okay. So a couple things. I need this 3 to be only on this second log, so I'm going to move it to my exponent position. So now I can rewrite this as log x to the 5th minus log x to the 3rd is equal to 4. Well, remember your exponent rules. When you divide, you subtract. Okay, so we're going to switch this to a division problem. So this is log of x to the 5th over x to the 3rd is equal to 4. Okay, this is a long process. Be patient with yourself. Take your time. Look up your rules as you go until you get used to working with them and manipulating things. Then it kind of becomes second nature because there's really only like 4 rules to learn. So we have x to the 5th over x to the 3rd. That simplifies down to x squared equals 4. And now we are finally ready where we have this single value here to convert it. So I have 10 to the 4th power equals x squared. If I take the square root of both sides, then 10 squared would equal x. So x is equal to 100. Always double check and make sure that that is the right solution. Okay, so I know I went a little fast through that example, but I do want you to pause the video once again and try this next one on your own. Okay, here's the last one worked out for you. Notice you take one rule at a time. So if we have multiple logs, we need to see if we can get those down to 1. So this is your division rule because you're subtracting. Once we have a log on both sides, then it's just a matter of canceling those out. Now I have a rational equation, so just like last unit, that I need to solve. So I multiply this whole thing over to the other side. Now I have a quadratic that I need to solve, so I get it set to 0, factor and solve. Check for extraneous solutions. Otherwise, that's your answer. You can see over here I did a quick check. All right, and that is it. Let me know if you have any questions on this.